Can you hear me all right? Okay. So hi everyone. Today I will present our work on personalized explanations for hybrid recommender systems. This is joint work with James Schaffer, J. Pujara, John O'Donovan, and Lise Getoor. So the motivation behind our work is to combine two important lines of research: hybrid recommender systems and explanations. Hybrid recommender systems have been shown to improve accuracy by combining different signals, such as user preferences and social connections. However, they operate as black boxes, that is, they provide recommendations without explanations. The research question that drove our work is how can we effectively explain the complex and multimodal models used by hybrid recommender systems, and do that in a personalized way. So in this case, we saw an example of a recommendation with a hybrid explanation. By hybrid, we mean that the explanation consists of more than one style. So in this case, we recommend to the user the artist Nick Cave because her friend Cindy likes Nick Cave, and because this artist is tagged with rock that is in the user's profile. And of course, we want the explanations to be personalized. That is, if we have a different user to make the same recommendation, we need to show different evidence. So we need to show this particular user's artist, friends, and tags that are in her profile. And even better, we would like, if possible, to know which styles each user prefers. So it might be the case that this particular user does not like social-based explanations, but she prefers popularity-based. So we would like to have a framework that can identify that and show the explanation styles that are suitable for a particular user. We identified two challenges. The first challenge is how can we generate personalized hybrid explanations? Hybrid models are complex, far more complex than non-hybrid counterparts, so explaining the reasoning behind them is not straightforward. The second challenge is, after having generated the explanations, how can we present those to the users? There is a plethora of dimensions to take into account, but in this study, we focus on answering three very specific questions. The first question is, which explanation styles are preferred by users? For example, is it the case that users prefer item-based explanations over social-based, or no? The second question is, how many explanation styles should we show to the users so as to sufficiently explain a recommendation and at the same time not overload them with a lot of information? And the third question we would like to answer is, which presentation format should we use when showing an explanation? Is it the case that users prefer simple text as explanation, or do they prefer visuals, such as Venn diagrams, for example? Our contributions are twofold. First, we extended an existing hybrid recommender system, and we implemented a translation mechanism to generate hybrid explanations. Afterwards, we conduct a personalized user study where we experiment with different explanation styles. We vary the number of explanations that we show to the users. We manipulate the presentation format. And finally, we consider user personality traits as a control variable. To generate the hybrid explanations, we extend a hybrid recommender system that is called HYPER, which stands for Hybrid Probabilistic Extensible Recommender, and it is a hybrid recommender system that can combine any number of information sources. Hyper underneath uses probabilistic soft logic, a generic probabilistic reasoning framework. Models in probabilistic soft logic are defined as a set of template rules in first-order logical syntax. In more detail, each template rule captures a different signal. Here are two examples of template rules in a music recommendation setting. The first rule comes from the item-based collaborative filtering approach and indicates the intuition that if we have two items, I1 and I2, that are similar, and we know that a particular user listens to item I1, then we may infer that this user will also listen to item I2. The second rule comes from the social-based filtering, and the intuition behind this rule is that if we have two friends with similar tastes, U1 and U2, and we know that U1 listens to item I, then we may infer that U2 will also listen to the same item. When data become available, a process called grounding takes place in order to combine the rules with data. Here we saw an example of groundings for the template rules we just described. For example, in the first ground rule, we know that the artists AC/DC and U2 are similar, and we also know that the user Mary listens to AC/DC. So we may infer that user Mary will also listen to U2. Similarly, in the second ground rule, we know that Mary and Cindy are friends with similar tastes. We know that Cindy listens to U2, so we may infer that Mary will also listen to U2. So in these two rules, given the evidence about item and friend similarities and past music preferences, we want to predict the value of listens Mary, U2, which indicates the probability that the user Mary will listen to the item U2. And to make the predictions, we use the set of ground rules to define a probabilistic graphical model. We perform inference over this model to generate predictions for the unobserved listens U, I. Let's now describe how we generate hybrid explanations from ground logical rules. Given the set of all ground rules for a particular user item combination, we need to write a parser that translates ground logical rules to natural language explanations. So in this case, the first ground rule will be translated to people who listen to your profile item AC/DC also listen to U2. And the second rule will be translated to your friend Cindy likes AC/DC. Here is an example of a hybrid explanation using natural language. In this example, we recommend to the user the artist U2 because of 7 different reasons. Each reason belongs to a specific style. For example, the first reason belongs to the social-based style. And note that although the styles are fixed, their content is personalized to its user's data. After having implemented a method to generate explanations with recommendations, the next step is to conduct a personalized study in order to answer the questions that we defined at the introduction of the talk. The questions are, how does explanation persuasiveness vary with different explanation styles? What is the ideal number of explanation styles? And how do explanation formats affect user experience? We use Amazon Mechanical Turk and we recruit 198 users. These are the users after filtering out the spam users. And we want these users to have an active Last.fm account. So we conduct a study using the Last.fm music recommendation platform. We conduct the study in 2 phases that I will now describe. In the first phase, we ask the user to answer a pre-study questionnaire, and we also ask for her Last.fm ID. Qualtrics that hosts the study takes this ID and passes it to the hyper model, which in turn sends this information to the crawlers. The crawlers request friends, artists, and tags from Last.fm. When the crawling is done, all the data are fed back to Hyper that runs in real time and generates recommendations along with explanations. These results are passed to Qualtrics that shows to the users those along with some questions. And we note here that we tried to do the experiment in real time, so the user had to wait around 10 minutes for the crawler to crawl all the data from Last.fm, and then around one additional minute for the PSL model to run and generate the recommendations and explanations. So to answer the question how explanation persuasiveness varies with different explanation styles, we work as follows. We show to the user a recommendation item, in this case we show REM, along with only one explanation style. In this case we show a social-based style. And we ask the user to answer the question, how persuasive is this explanation, from 1 to 7. We continue by keep recommending the same artist, but in this case, we changed the explanation style. So now we show a content-based explanation style and ask the same question. And we keep working in this way until we show all the explanation styles that are supported by our framework. Here we plot the mean persuasiveness with respect to the different explanation styles. And we observe that people prefer item-centric over socio-centric explanations. So the explanations that involved other items in order to support a recommendation were more favorable when compared to explanations that involved Last.fm users or popularity-based explanations. To answer the question, what is the ideal number of explanation style, we show to the user a recommendation, and we also gave her a list of different reasons that this recommendation was made to her. And we ask the user to rank all those reasons from the most persuasive to the least persuasive. We gave the user the option to rank from 0 to the maximum number of explanations that she thought that it is persuasive. So a user might choose not to rank anything or to rank only 3 styles or anything that the user liked. Interestingly, 40% of the users chose not to rank any style. After deleting those users, the mean number of explanation styles was 4.3. So we reached the conclusion that people prefer to see approximately 3 to 4 explanation styles. And this is an important finding which shows that if we have a complex hybrid recommender system that uses a variety of signals and information sources to make a recommendation, we should not show everything to the user because she will be overloaded. Instead, we need to carefully choose which explanation styles we need to show here. To answer the question, how does user experience varies with explanation formats, we implemented the best visual formats that were a result of a non-personalized user study. So we implemented Venn diagrams using 3 intersections, a cluster dendrogram, 2 versions of it, an interactive and a non-interactive one, and also a textual explanation in natural language. And again, we show to the user the same artist with different visual format and ask her to rate how much she agrees with the statement. This explanation for the recommendation is convincing. And here we plot the mean subjective persuasiveness with respect to the different formats. And we observe that textual explanations are preferred. So if we would like to implement an explanation component in a recommender system, probably going with implementing a natural language component would be a good option. In this work, we additionally considered user personality traits. So in the pre-study questionnaire, we asked the users questions related to the 5 basic personality traits. And the findings show that a person's personality significantly correlates with perceived persuasiveness. In more detail, we observed that participants that reported to be calm preferred popularity-based explanations, while participants that reported to be anxious preferred item-based collaborative filtering explanations. We also observed that participants that are reported to be dependable were likely to rank less explanation styles, while participants that reported to be open were likely to rank more explanation styles. And I would like to note that there is more work that I didn't have the time to show in this presentation. So in this paper, we additionally validated the quality of the online recommendations in terms of accuracy and novelty. We found that our method is accurate enough, but does not provide very novel recommendations. We performed a separate analysis for experienced versus novice Last.fm users. And we also evaluated the Hyper framework in an offline setting where we compared its accuracy with other baseline collaborative filtering methods and saw that our framework has improved accuracy. So to conclude, we implemented an explainable AI system in the recommender systems domain, and we saw how we can turn probabilistic models to explanations that are easily understandable by humans. We additionally performed a personalized user study where we investigated what people want from explanations, and we found interesting patterns between explanations and personality traits. We believe that the results of the study can be used from designers of explainable interfaces. Finally, we believe that there is a lot of exciting research in the area of explanations and hybrid explanations in particular. So we would love to explore how the results that we got can be applied to other domains. For example, what happens in the job recommendation domain, where the decision that the user will take to accept or reject a recommendation will affect his career instead of the next track that she will listen to. Is it the case that the user is satisfied with seeing 3 to 4 explanation styles? Or is it the case that the user wants to see all the information that the recommender system used in order to come up with this recommendation? And finally, we're very interested in working towards providing privacy-aware explanations. Thank you very much.
Questions?
Hi, Pigi. Thanks for a really interesting paper. I was actually looking for that for the whole 3 days of conference. So I have a very easy question. So far, your assumption for comparing text explanation is that item is recommended by multiple sources. It is recommended because they're friends. It is recommended because like text. But in fact, in many cases, there is only one source. This item is recommended because there are similar texts. There's just only one explanation to show. There is no choice. But it's a more complicated case. The strength of recommendation with different sources may be very different. So for example, there is a very weak recommendation based on friends and a very strong recommendation based on text. However, user prefers friend recommendation. Should we justify a recommendation using very weak source while in fact recommendation has been obtained by using strong source? You didn't really cover that issue in the talk.
Yeah, yes, thank you for the question. This is a difficult question, actually. So, yes, I agree that there are these things that we need to take into account. We didn't take them, so the intuition is that each source equally contributed to do the actual recommendation. So there were many decisions to take in order to implement this study. So for this first study, we went with the simple approach. Of course, we have worked in the previous work we have done in the non-personalized study, where we have shown mock-ups to the users. We have shown how much percent each recommendation, each explanation played to the final recommendation. And there we found that users didn't find any difference between showing them how much this explanation played to the actual recommendation. So based on this outcome, in this study, we didn't look at this very interesting thing. Yeah, but this is very interesting, of course, and there are many, many things that I didn't have the time to cover and we didn't have the time to implement in this paper because it's very broad what we can and what we cannot do, so we had to focus. But thank you, this is very, very good question.
Hi, thank you for the talk, very clear, very interesting. My question is about a bit related to this framework, the software probabilistic logic. I remember having seen your advisor one giving a talk. It was really interesting that she was mentioning that although you provide logic statements and they are true or false, in the backend you also have an optimization engine that works automatically. So my question is, when you say similarity, that similarity is just given by the data that you crawl from Last.fm, so these are similar artists because Last.fm says, or you are actually calculating the similarity between artists based on your engine?
Yes, so very good question again, thank you. So we used multiple similarities in our model because this is a hybrid model, so we can use whatever similarity we want. So for this work, we used an artist similarity that is provided by Last.fm. So we had a rule here. This Last.fm's, So for example, this Last.fm's data indicates that U2 is similar to Coldplay. Here we use the similarity provided directly from Last.fm. In this case, people who listen to your profile item ACDC also listen to U2. It is a similarity that we computed using collaborative filtering, the cosine similarity. And we also were able to use here Jacquard similarity using on the content, so using tags. So since the model is hybrid, we can compute any kind of similarity we would like and provide any kind of explanation style.
Hi, Pigi. Nice talk. I was wondering about, I got triggered by the slide of the comparison of these, right? So you showed that the kind of similarity and utility ones were kind of doing better than the social ones. And I did a study a while ago that was in a completely different domain, but used also very similar social and more utility-based explanations. And I also asked people which of these explanations is more convincing. And everyone said, no, the social explanation, that's not convincing because I'm not influenced by what other people are doing. But in that study, I also had actual behavior. And I found that the one condition in which people were actually influenced by the explanation was the social condition. So people say that they can be, that they won't be influenced by that, or that that's not persuasive, but it might still be persuasive in their actual behavior. So I was wondering, do you have a plan of kind of looking at actual behavior with this as well, or kind of implementing this in a system where people would actually be using this?
This is a nice suggestion for future work. We didn't do that in this work. However, I'd like to note here that the social-based performed not well, but you can see that there is a big standard deviation. And this is because we had many users that didn't have friends in Last.fm. So although at the beginning of the study, we told them in order to participate, you need to have at least 10 artists in your profile and 5 friends. We checked that they do have 10 artists. So if they didn't have 10 artists, then they couldn't continue with the study, but we didn't check on the friends. So we got many users that didn't have friends. So yeah, this is one of the issues with Amazon Mechanical Turk studies. But of course, your note is very interesting, and it's very good to work on it in the future.
Okay, thank you so much. And I forgot to mention, but this was nominated for our best paper. So. All right, I am presenting